Thank you, Faisal. As my friends already told you, we are using flip-flop in this circuit. But before going into the details, I would like to tell what flip-flop is and how it works. Flip-flops are nothing but a sequential circuit. They use feedback as input. They can store data. And the most important thing which differentiate between a latch and a flip-flop is that while latch uses signal level as input, flip-flop uses clock inputs. Now, anybody can ask why we are not using latches, because latches can also store data. But latch produces an undetermined state of an undefined condition, and we have to make sure that both inputs are never at any state 1-1. While on the other hand, flip-flops are designed in such a way to work in a sequential circuit which employs a common clock. Now, before going into detail of the flip-flop and magnification, this part I want to tell you what type of flip-flop we are using here. As you can see here, we have employed 2D latches, one master and one slave, in master-slave configuration. Both have enabled keys. Both enabled keys are connected with the inverter, and inverter input is connected to the output. T-cap flip-flop is which can store data, and it is employed to store data. What is T-cap flip-flop? T-cap flip-flop is employing D latches. SR flip-flop and D flip-flop. So in SR flip-flop we use as an R set, D set, while in T-cap flip-flop we can use D set and clear reverse. Last with the Y is flip-flop is flip-flop, flip-flop, SR flip-flop quite similar except big feature. It is different because it is a preset. We can only make the flip-flop from SR flip-flop. So we used to we will connect 2 more NAND gates with the SR flip-flop, preset and delivered, and we will employ a clock input. One thing we are calling clockers. Then the importance of SR. Yes, sir. This is the main factor. But the main factor we are talking about here is that the configuration. Okay, so now continuing. Let's say the first input is 1. Now what will happen here in this master-slave configuration? This input clock will enable the master latch, but due to this inverter gate, this enable key will receive a 0 and this slave is input. Irrespective of the data input, let's say it is 1, this will channel to the Y output. But due to the disabling of the slave latch, this signal will not be channeled to the Q. Now coming to the second input, this Q. Now when the clock is 0, of course everybody knows that enable is disabled and master latch is disabled. But due to the inverter gate, again we have a 1 input and slave latch is open. Now the working of flip-flop is this 1 will be channeled to the Q output. What we are concluding here is that flip-flop output only changes with the transition of the clock output 1 or 0. Okay, now coming to the flip-flop magnification part. We have used 7472 ICs and C40 and 7 ground and VCC. Now, this is the password. We are using 4-bit password, and this will be delivered from a keypad. Okay. Now, pin number 2 and pin number 12, A1 and A2. You see here A1 and A2, and similarly with the second circuit, pin number 2 and 12. Both flip-flop 7472 ICs will receive password on the pin number 2 and 12. This will be saved by the mechanism which I have already told you. Now, after saving this password, this keys of saving password will be channeled to the next portion of the circuit, which is the grid comparator with the help of pin number 9 and pin number 6. Now, my friend, I think we told you about the working of magnet comparator and further on. Thank you very much.
Thank you, sir. My name is Mohammed. I am here to tell you about magnetic comparator. Magnetic comparator is a combination circuit which compares two binding numbers. As the password is already saved, the magnetic comparator is used to check or verify that password. Here in our project, we use two magnetic comparator IC7484. Each comparator is used to verify 2 bits. If the password is saved, means A is equals to B. A is the storing, B is the user is saved. The output will move towards AND gate and green LED will turn on. Means lock will be open.
It's not compared करेगा. Bit by bit और level lock. इसके लिए करेगा पहले.
सही स्टोरेज कंपेयर करें आउटपुट यहाँ से
D3 को A3 से D2 को A2 से यहाँ से bit by bit कंपेयर करेगा और just randomly करेगा.
If the password is not saved, means A is not equal to B. Then A is greater than B or A is less than B. The output will move towards AND gate. Then the output will be then the red LED will turn on and the power will come from the store input and output.
क्या है condition होती है कंपेयर?
But A is equals to B. A is less than B or A is greater than B. Then red LED will turn on and lock will not go. This is all for my fact. Now the rest of the presentation will be done.
You can take a sort of one.
Now I begin overview of this digital log for all of you. First, we have two flip-flops and we have two magnetic comparators, one AND gate and one NAND gate. First of all, we will save password in the flip-flops. Here, two passwords will go to the first flip-flop and the other two passwords will be saved by the second flip-flop. After this, these flip-flops are connected to the magnetic comparators. These first two passwords will be verified by this magnetic comparator.
2 bits of the password or 2 password?
And these 2 bits of password will be compared by this magnetic comparator. Which they will compare from this user input which we give. So the first two inputs will be compared with these saved bits and the other two password bits will be compared with these this saved flip-flop bits. If the password is correct,
7474 is IC for the flip-flop back. 748 is the comparator IC.
okay, now these both magnetic comparators are connected with AND gates and NAND gates. If the password is correct, means the output is 1. So the output is 1 and the AND gate will perform and 1 will go to the green LED and lock will be open. If there is 1 0, the password is not verified, and if there is 1 0, then 1 0 will go to the NAND gate and NAND gate will perform, and after that it will just open and red LED will turn on and speaker will start. That's all from my side. If you have any questions, please ask.